Halina mga bata, tayo nang mag-aral. Sa math, walang maiiwan. Math-sayang, math-aral, tayo ng math-tuto upang ika'y umasenso. Maging matyaga, maging matalino, halina't math-aral na tayo. Maging matyaga, maging matalino, halina't math-aral na tayo. Halina math-aral na tayo. Halina, 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 math-aral na tayo.
Hello, madlang Mandaluyong. Welcome to our project store, series of online academic reviews of mathematics CLAID learning module for week 6. I am Teacher Nat, a teacher from Highway Hills Integrated School. Sa lahat ng ating mga viewers sa tanghaling ito, huwag kalimutan i-share ang videos, mag-host ng watch party, i-share ang official Facebook page, Math Team, Mathematics Teachers Association of Mandaluyong, at mag-subscribe sa YouTube channel, NTM channel, para maging updated sa aming mga video lessons. Magandang tanghali, Batang Mandunong. Kanina napakinggan natin ang advanced study sa week 6 of Mathematics 8 CLAID learning modules. Ngayon naman, dadako tayo sa week 6 of Mathematics 9 CLAID learning modules. To introduce our speaker, she is teacher 2 and now she is 7 years in service at Isaac Lopez Integrated School. She is grade 9 level head and Mathematics 9 teacher. Let's all welcome Miss Juno Omega T. Camacho.
Thank you, sir. To our officer in charge, Office of the Schools Division Superintendent, Dr. Romela M. Cruz, Sese. To the officer in charge, Office of the Assistant Schools Division Superintendent, Dr. Aurelio G. Alfonso. Mrs. Emma G. Arubio, Chief of School Governance and Operations Division, Dr. Aline G. Mendoza, Chief of Curriculum and Implementation Division, all education program supervisors, EPS in Mathematics, Mr. Restituto Ira Delas, and public school district supervisors. To our school principal, Mr. Roberto Piredobante, viewers, teachers, home learning partners, and to all Batang Mandunong, a pleasant day. And welcome to Project SOAR, series of online academic reviews of mathematics CLAID learning modules. I am Teacher Juno of Isaac Lopez Integrated School, your math buddy for today's lesson in Mathematics 9.
Good day, everyone, and welcome to another series of online academic reviews of Mathematics 9 CLAID learning modules. I am Teacher Juno, your math buddy for today. For today's session, we will be discussing about quadratic functions. But before we start our discussion, let me share with you the following objectives. First, to model real-life situations using quadratic functions. And second, to represent a quadratic function using table of values, graph, and equation. Let us start our discussion with modeling real-life situations using quadratic functions. In modeling real-life situations of a quadratic function, look all the formulas to be used on the problem. It is very important to analyze the problem carefully to check what is being asked, And what are the given values on the problem? Note that linear function can also be applied in modeling quadratic function. There are many possible strategies you can use in modeling real-life situation of a quadratic function. In this case, you can use these steps to model your quadratic function involving real-life situations. First, identify what are the formulas to be used on the problem. Second, substitute the variable or variables by its given values on the problem. Third, express the formula in terms of one variable. And fourth, combine the formulas to model the quadratic function. For example, one campus of Rizal Technological University has plans to construct a rectangular parking lot on land bordered on one side by a highway. There are 24 meters of fencing materials available to fence the other three sides. What dimensions of the parking lot will give a maximum area? Before answering the question on the problem, let us model a quadratic function to this problem by considering some concepts that will support to this problem. In the figure on the right, there are two formulas to be used to solve the problem. These are the perimeter and the area of the rectangle. If we let W be the width and L be the length of the parking lot, we will have the expression below as the sum of the measures of the three sides of the parking lot. 24 equals W plus W plus L. 24 is equal to twice the width plus length. Next is to solve the expression for length in terms of width. Thus, 24 equals twice the width plus length. By applying addition property of equality, we can add negative 2W to both sides of the equation. Then, it will become 24 minus 2W equals L. Applying symmetric property of equality, we will have length is equal to 24 minus twice the width. Based on the problem, you are asked to find the dimensions of the parking lot that will enclose a maximum area. In this case, we must express the area of the parking lot in terms of one variable, which is the width. The formula for area is length times width. Earlier, we solved the expression for length in terms of width, wherein length is equal to 24 minus twice the width. Now, to express the area of the parking lot in terms of one variable, which is the width, we have to substitute 24 minus twice the width to the length. That is why we have area or A is equal to quantity 24 minus 2W times W. Simplifying the equation, A will be equal to 24W minus 2W squared. As you can see, the area is in quadratic form, and this is what we called mathematical model of quadratic function. Using this mathematical model, let us complete the table below by substituting the width by its given values in area equals 24W minus 2W squared. Can you try to solve the area when the width is 7 and 8? What do you think is the independent variable? How about the dependent variable? By substituting the given set of values for width in our mathematical model A equals 24W minus 2W squared, the following set of values for area are determined. Like for when the width is 7, the area is equal to 70. And when the width is equal to 8, the area is equal to 64. In the table of values, the width is the independent variable since it can be freely varied, while the area is the dependent variable since it is affected by a change in input in width. By checking the values of the area, notice that the maximum measurement of the area is 72 square meters. It indicates that the width of the parking lot is 6 meters. To find for the length, we are going to substitute the value of width, which is 6 meters, to the expression we had earlier, which is length equals 24 minus twice the width. Substituting 6 to our equation, we will have length equals 24 minus 2 times 6. Simplifying the equation, we will have length equals 24 minus 12. Length is equal to 12 meters. Therefore, the dimensions of the parking lot that will enclose a maximum area is 12 meters by 6 meters. To graph the quadratic function using the table of values, let the width be the x-coordinate since the width is our independent variable, and area be the y-coordinate since the area is our dependent variable. Using the ordered pairs, plot the points on the Cartesian plane and connect them using a smooth curve as illustrated at the next slide. If we are going to describe the graph of the given quadratic function, it is an inverted U shape. Now, for our next topic, I will discuss about how to represent a quadratic function using table of values. Quadratic functions are functions that can be described by equations of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a should not be equal to 0. The highest power of the independent variable x is 2. Thus, the equation of quadratic function is of degree 2. The following are examples of quadratic functions. We have y equals quantity x plus 5 squared, y equals negative 2x squared plus 9, 3x squared minus 4x equals y, and y equals x squared minus 7x plus 6. As you can see, all of them have a degree of 2. In representing a quadratic function using table of values, it is very important that we know how to make a table of values. In making a table of values, we need to have a set of x values and set of y values. So how are we going to do that? Let us recall how to make a table of values representing a function. So I have here an example. Given the equation y equals 3x minus 6, if x is equal to 4, what would be the value of y? By substituting the value of x, which is 4, in the equation, we will have y equals 3 times 4 minus 6. Subtract 6 from 12. Therefore, we have y equals 6. Thus, the value of y is 6 when x is equal to 4. When x is equal to 2, the value of y is equal to 0. I have here an example of a table of values that represents a quadratic function. By looking at the given equation, we can easily say that it is a quadratic function since it has a degree of 2. With a given set of x values substituted in the given quadratic function, the set of y values are determined. Now, let us examine the table of values. I solved for the differences in x values and in y values. As you can see, the second differences in y values are the same. Thus, a table of values represents a quadratic function if and only if the second differences in y values are the same. The following examples are table of values that represents a quadratic function. Now, let us check your understanding about the concept. Determine whether the given tables of values represent a quadratic function or not. Now, let us check your answers. For number 1, the given table of values does not represent a quadratic function. Why? Because, as you can see, in the first difference in y values, they are already the same. While in number 2, the given table of values represents a quadratic function. Because in the second differences in y, they have the same difference, which is 10. How about representing a quadratic function using graph? The graph of a quadratic function is a curve called a parabola. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U shape. To determine whether the parabola is opened upwards or downwards, we must take the equation into account. For any parabola, y equals ax squared plus bx plus c, if a is greater than 0, then the parabola opens upwards. And if a is less than 0, then the parabola opens downwards. For example, we have quadratic function f of x equals x squared minus 6x plus 5. As you can see, the value of a is equal to 1, and 1 is greater than 0. Since the value of a is greater than 0, the opening of the graph of the given function must be upward. To sketch the graph of the given quadratic function, we have to complete the table of values. We have to substitute the value given for x into the function to determine the set of y values. For f of x equals x squared minus 6x plus 5, where x is equal to 0, by substituting 0 for x, we will have f of x equals 0 squared minus 6 times 0 plus 5. Therefore, f of x or y is equal to 5. When x is equal to 1, we will have f of x equals 1 squared minus 6 times 1 plus 5. The value of f of x is equal to 0. When x is equal to 2, the value of f of x is equal to negative 3. When x is equal to 3, the value of f of x or the value of y is equal to negative 4. When x is equal to 4, the value of y or the value of f of x is equal to negative 3. When x is equal to 5, substitute the value of 5 in the quadratic function f of x equals x squared minus 6x plus 5. The value of f of x will become 0. When x is equal to positive 6, the value of f of x or the value of y is equal to 5. Next step is to graph the points from the table of values. As you can see, the graphical representation of the given quadratic function f of x equals x squared minus 6x plus 5 is a U-shaped curve that opens upward. For example number 2, we have f of x equals negative x squared minus 6x minus 1. As you can see, the value of a is equal to negative 1, which is less than 0. Since the value of a is less than 0, the opening of the graph of the given quadratic function must be downward. I have here an incomplete table of values. To complete the table, try to solve for the value of y when x is equal to negative 1 and x is equal to 0. Alright, y is equal to 4 when x is equal to negative 1. And when x is equal to 0, the value of y is equal to negative 1. Now, try to graph the quadratic function by using the table of values that we have completed. As you can see, the graphical representation of quadratic function f of x equals negative x squared minus 6x minus 1 opens downward since the value of a is less than 0. For our last topic for today's session, I will discuss how to represent a quadratic function using equation y equals ax squared plus bx plus c. Remember, quadratic functions can be described by equations of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Therefore, we can use this form of equation in representing a quadratic function. In our previous discussions, I gave some examples of quadratic functions. As an exercise, let us recall how to determine whether a given equation is a quadratic function or not. Tell whether the following equations are quadratic functions or not a quadratic function. Now, let us check your answers. For number 1, it is a quadratic function. Number 2, not a quadratic function. 3, quadratic function. 4, not a quadratic function. And number 5, quadratic function. Equations 1, 3, and 5 are quadratic functions because the equation has the highest degree of 2 and it is in a quadratic term. While equation 2 and equation 4 are not quadratic function because the equation has the highest degree of 1 and it is in a linear term. Considering the given quadratic functions in the activity, which are quadratic function 1, y equals x squared plus 8x minus 7, and quadratic function number 3, which is y equals negative 5x squared plus 2, they are expressed or represented in the form y equals ax squared plus bx plus c. While quadratic function number 5, y equals 4 times the quantity x minus 2 squared, is not written in the form y equals ax squared plus bx plus c. So if we are going to represent quadratic function number 5 in the form y equals ax squared plus bx plus c, how are we going to do that? For example, we have y minus x squared equals negative 7. To represent the given quadratic function in the form of y equals ax squared plus bx plus c, we need to apply the addition property of equality by adding positive x squared to both sides of the equation. By simplifying the equation, the resulting equation will be y equals x squared minus 7. So the standard form of y minus x squared equals negative 7 is y equals x squared minus 7. For our next example, we have quadratic function f of x equals quantity x minus 3 times quantity x minus 5. To represent the given quadratic function in the form of y equals ax squared plus bx plus c, we have to multiply the two binomials. So we will have f of x equals x squared minus 3x minus 5x plus 15 by applying the FOIL method. Then, simplifying the equation, we will have f of x equals x squared negative 8x plus 15. Thus, the standard form of the given quadratic function f of x equals quantity x minus 3 times quantity x minus 5 is f of x equals x squared minus 8x plus 15. Now, it's your turn. Write the quadratic function in the form y equals ax squared plus bx plus c. Now, let us check your answer. To represent the given quadratic function y equals negative 3 times quantity x minus 5 squared plus 1 in the form of y equals ax squared plus bx plus c, we have to simplify first to the quantity x minus 5 squared by applying the FOIL method. This will result to x squared minus 5x minus 5x plus 25. So we will have y equals negative 3 times the quantity x squared minus 5x minus 5x plus 25 plus 1. Simplifying the equation inside the parentheses, we will have y equals negative 3 times x squared minus 10x plus 25 plus 1. Applying distributive property of multiplication, we will have y equals negative 3x squared because we will distribute negative 3 by multiplying it with x squared minus 10x plus 25. So we have negative 3 times x squared, that is negative 3x squared. Negative 3 times negative 10x, that is positive 30x. Negative 3 times positive 25, that is negative 75. So we have y equals negative 3x squared plus 30x minus 75 plus 1. Simplifying the equation, the resulting equation will be y equals negative 3x squared plus 30x minus 74. Therefore, the standard form of quadratic function y equals negative 3 times quantity in x minus 5 squared plus 1 is y equals negative 3x squared plus 30x minus 74.
And that's all for today. I hope that you learned something from me. Thank you for watching and happy learning!